Good morning and welcome to today's briefing on the increasing role that CubeSats, tiny inexpensive satellites, are playing in exploration, technology demonstration, scientific research, and educational investigations at NASA and throughout the space community. A United Launch Alliance Atlas V rocket is poised for liftoff tomorrow at 5:49 a.m. Pacific time from Vandenburg Air Force Base in California, where we are today. And riding along as an auxiliary payload are 13 CubeSats. 4 of the CubeSats are NASA-sponsored, and 9 of them are National Reconnaissance Office, or NRO-sponsored, and one of those was developed with NASA funding. All will be flown on the NRO's Government Rideshare Advanced Concepts Experiment, or GRACE, which is an auxiliary payload aboard the NROL-55 mission. And to talk about the growing role CubeSats are playing, we're pleased to be joined today by Steve Jerzik, Associate Administrator for the Space Technology Mission Directorate at NASA headquarters in Washington. Megan Hubble, Deputy Chief, CubeSat Program Office, the National Reconnaissance Office. Sherry Zacharias, Vice President, Technology and Laboratory Operations for the Aerospace Corporation. John Serafini, Vice President at Allied Mines and Chief Executive Officer for both BridgeSat and Hawkeye 360. Andrew Petro, Small Spacecraft Technology Program Executive at NASA. And Scott Higginbotham, NASA Launch Services Program ELANA 12 Mission Manager. So for those of you watching on TV or through the web, we will be taking questions today on social media during the Q&A portion using the hashtag AskNASA. Kimberly Williams from NASA's Ames Research Center Public Affairs Office is here, and she is looking for incoming messages, and we will be happy to take those questions a little bit later on. For media who have dialed in on the phone, a reminder to please press *1 to be placed into the queue. And we'll begin today's briefing with a few opening remarks. Steve.
Thank you, Mike. It's great to be here today as we prepare for the first launch of NASA's and Aerospace Corporation's Optical Communications and Sensor Demonstration, OCSD mission. I want to thank the NRA for providing the launch opportunity and Vandenburg Air Force Base for hosting us. As many of you know, NASA has several small spacecraft or CubeSats on tomorrow's launch. NASA's CubeSat Launch Initiative, CSLI, enables the launch of CubeSat projects designed, built, and operated by students, teachers, faculty, and government researchers. Also, NASA's educational launch of nanosatellites, ELANA missions, managed by the Launch Services Program at Kennedy Space Center in Florida, launched the CubeSats selected through CSLI into space. We hear from several people on this panel and the second panel about some of those very innovative CubeSat missions. You may be asking, why is NASA investing in small spacecraft and CubeSats? We believe our investments will, first, advance the capabilities of small spacecraft to support NASA missions in exploration, operations, and our 4 science disciplines: planetary science, earth science, heliophysics, and astrophysics. To perform missions or examine phenomena not otherwise possible, accelerate the introduction of new small spacecraft technologies and capabilities, and unleash NASA's unique capabilities and assets into the already vibrant small spacecraft community. Our Small Spacecraft Technology, or SST program, of which OCST is an element, as well as our Science Mission Directorate and Human Exploration and Operations Mission Directorate, develop and demonstrate new small spacecraft technologies and capabilities for NASA's missions. Our ultimate goal is to promote small spacecraft as a paradigm shift for NASA and the larger space community. The SSTP is one of 9 programs in the Space Technology Mission Directorate. The program is managed by NASA Ames Research Center at Moffett Field, California. Ames has pioneered most of NASA's small spacecraft missions. NASA's Space Technology Mission Directorate, which is responsible for this technology demonstration, is committed to developing the critical technologies and capabilities required to enable future exploration missions beyond low Earth orbit. In order to explore an asteroid or one day land humans on the surface of Mars, we will need sustained and substantial investments in advanced space technologies. We will likely need the new capabilities we are demonstrating with these CubeSats on our future missions into deep space. Without these investments, we will not be able to move humans beyond the International Space Station. In essence, technology drives exploration and our journey to Mars. Also want to take a quick moment to talk about our CubeQuest Challenge, an element of our Centennial Challenges program. Non-government CubeSat builders will vie for a launch opportunity to lunar orbit aboard a rocket on a future deep space mission. From there, they will compete for achievements in communication and deep space longevity and prizes totaling $5.5 million. And now I'd like to turn it over to Megan, and thanks.
Thank you very much. And I'd like to take this opportunity to thank NASA for inviting us here today to join the panel. Tomorrow, the NRO will be launching L55, which is only the third NRO launch of its kind that will provide ride share to an auxiliary payload of CubeSats. The GRACE mission will be hosting 9 CubeSats sponsored by the NRO and 4 by NASA. NRO and NASA have a long-standing partnership with regards to CubeSats, where we exchange rideshare opportunities and lessons learned when available. The NRO recognizes the utility of CubeSats as a cost-effective way of exploring new technology and concepts of operation, and CubeSats are a great way to inspire innovation and cool science. That's why the NRO is committed to supporting government partners as providing free ride to space on select NRO launches and by sponsoring experiments to demonstrate new technology and capabilities that benefit not only the NRO, but the larger space community. So I'd say we're definitely looking forward to tomorrow's launch. Thank you. Sherry?
Good morning, and I'm very pleased to have this opportunity. I'm Vice President of Technology and Laboratory Operations at the Aerospace Corporation located in El Segundo, California. Aerospace is a nonprofit corporation that operates a federally funded research and development center. We act as an advisory role to government regarding space enterprise. Aerospace has been involved with CubeSats or PicoSats for over 20 years. We launched our first PicoSat in 1999, and initially our activity was funded by DARPA and internally funded. We now have paying customers, customers being our primary government customers and NASA. And initially, the balance between innovation and risk was about even. They were very highly innovative and also very highly risky. As we've learned over the last 20 years, by learning from our previous mistakes and increasing our experience, I'm happy to say that the risk has gone down, the reliability has gone up, and our innovation has stayed very high. We initially turned our focus on demonstrating technologies, and we now are looking at enabling technologies so that future missions are possible. Small satellites are really just the same as big satellites. They have all the same subsystems and many of the same requirements. So aerospace has developed appropriate power systems, communication systems, navigation systems, attitude control and pointing systems, as well as automated ground systems. We currently operate 3 RF ground systems and 1 optical ground system, with one of each about to come online shortly. Tomorrow's launch will be of the Optical Communication and Sensor Demonstration, or OCSD. This is a partnership between aerospace and NASA, and it will demonstrate high-speed optical transmission of data. In a future launch early next year, we will launch 2 companion satellites, which will demonstrate small satellite proximity operations. This is a great example of a partnership between aerospace and NASA, enabling technologies that will then be available for the entire community. Lastly, I want to talk about something that I feel pretty strongly about, and that's that the CubeSat program at Aerospace has enabled our scientists and engineers to really get a hands-on feel for what it's like to begin a project, determine what the requirements are, and then see it all the way through to launch and operations. In the satellite world, that's a pretty rare thing to happen, and it really gives our scientists and engineers the opportunity to be creative and innovative, as well as really get a feel for what it means to deal with a whole system. And with that, I'd like to turn it over to John.
Thank you, Sherry. Hi, I'm John Serafini. I'm a venture capital investor with Allied Minds, where I lead our two investments in low Earth orbit technologies, namely BridgeSat and Hawkeye 360. Allied Minds is a differentiated venture capital investment firm. As a publicly traded holding company, we specialize in creating new companies from scratch around disruptive, transformational intellectual property that we find in U.S. universities and federal research labs. Given the amazing cost efficiencies to be gained through LEO-based investments and the new revenue models available through the commercialization of those capabilities, we have been active investors in what many call new space. For the past nearly 2 years, Allied Minds has been working closely with Dr. Rich Welly and the rest of the SmallSat team at Aerospace Corporation to leverage the capabilities developed under the OCSD program to achieve commercial optical downlink as a service via a proprietary mesh network of small satellites that will interface with client spacecraft and downlink their data at speeds orders of magnitude faster and with much lower latency than what is offered today by RF capabilities alone. Tomorrow's launch is an extremely important milestone in the commercialization of this great OCSD optical transmission capability in providing strong evidence that rapid throughput can be achieved through the use of optical transmission on small satellite platforms. Tomorrow is 200 megabits per second. By Q1, we seek to demonstrate up to 622 megabits per second, and by the end of 2016, we're seeking to achieve 2.5 gigabits per second in throughput. So why is this compelling? First, and I think we're all very familiar with this problem, in that the amount of small sats today already in LEO, particularly Earth observation, are today generating an enormous amount of data. So much so that the paucity of expensive RF resources available today means that a material amount of this data, 15% to be precise, is actually lost in space. As the number of small satellites in LEO increases exponentially over the next 10 years to upwards of nearly 3,000 small sats, and the payloads of these small satellites get increasingly more sophisticated in generating new data with synthetic aperture radar systems and live video platforms and hyper and multispectral imaging capabilities, the amount of data to be generated over the next 10 years is estimated at up to 32 exabytes of total data. Simply put, without a new alternative for data transmission that is faster, with lower latency and greater security, it's clear that with just RF capabilities alone, the amount of future data to be quote-unquote lost in space will also increase exponentially. The second reason driving the need for optical transmission is its promise for low latency. Imagine a scenario where data generated in LEO could be available to terrestrial users not within days or hours, but within seconds. That promise can only be achieved with a mesh network of optical transmission capabilities. We demand immediate access to our data here on Earth, so much so that we get angry if our web browsers don't load within 2 seconds. Why don't we demand the same of data that has originated from low Earth orbit? Well, BridgeSat will make that a possibility. Finally, we have recently established a second company named Hawkeye 360 for the commercialization of intellectual property developed at Virginia Tech, specifically for the geolocation and characterization of RF signals intelligence. Much more to follow about this new company in the future. With that, I'll pause and turn it over to Andy.
Okay, thank you. I'm Andy Petro. I oversee NASA's Small Spacecraft Technology Program, in which we are developing and demonstrating new technologies to enable greater capabilities for NASA's missions in science, exploration, and space operations. I'd like to begin by thanking the NRO for providing a ride to space for the optical communications and sensor demonstration. OCSD was selected by NASA back in 2012. It was one of only 3 projects selected from over 100 proposals, so it was a very competitive field. The Aerospace Corporation that's leading this project, also one of the other of the 3 from that set of projects, led by Rich Welly, who you'll be hearing from later. The aerospace team are pioneers in the field of very small spacecraft, and as they've proven, they're exceptionally creative and skilled engineers. And it's really been a pleasure to work with them over the last couple of years. We're also very excited about the commercial involvement that John talked about with BridgeSat. We're not only developing these capabilities for NASA and for the government, but we want to build the private industry in this field as well, and that's very helpful in that. OCSD is one of 6 flight projects we have underway right now, and we have 15 other projects in development. We are working with 9 different private companies, 12 universities, 8 NASA centers, and several other government agencies on these various projects. I'd like to go to the illustration just to give a little context of how OCSD, this mission fits into our overall portfolio of missions. Going back to 2013 and 2014, we flew 5 PhoneSat satellites, which were very simple, low-cost satellites, 1U CubeSats, that used a mobile phone as the basis of the control system. That architecture has been continued in the next series of satellites. Starting next month, at the end of this month, we'll be launching the Edison swarm, which is 8 CubeSats. This is an example I have here. Is a 1.5U CubeSat. You can see it's similar in size and shape to the OCSD, and it shows you the flexibility and the power of this platform for doing a wide variety of different types of missions in technology, science, and exploration. So in addition to the missions I described, the Edison and NODES missions going in the next 2 months, we have a suborbital flight of a very small capsule, which is another area of technology we're making advancements in. And then we come to the second flight of OCSD that was described, taking this technology further in laser communications and proximity operations for small spacecraft. And then we have a project led by JPL, also with aerospace, in which they will demonstrate a reflecting antenna, which is a way to increase the capability of radio communication. And then we have the CubeSat proximity operations demonstration called CPOD, led by TIVAC, another small private company. And that will demonstrate autonomous rendezvous and docking with 2 CubeSats, which will be another first for this type of activity with such small spacecraft. And then we have several, the series of additional projects in development to do demonstrations of propulsion, including electric propulsion, with 6U and in one case a 12U CubeSat coming in the future. So to conclude, we're hoping for a good launch tomorrow and lots of good things to come. Thanks. And I'll turn it over to Scott.
Thanks, Andy. Good morning, everyone. I'm Scott Higginbotham. I'm a mission manager in the Launch Services Program, and I'm the mission manager for Alana 12, 4 CubeSats that are flying on this mission that are sponsored by the CubeSat Launch Initiative. It occurred to me driving in this morning that our mission is something like a Matryoshka doll, a nesting doll. We have a mission within a mission within a mission. We have Alana 12 that's part of GRACE, that's part of L55. The 4 CubeSats that make up Alana 12 come from the full spectrum of providers that we work with in the CubeSat Launch Initiative. We have 1 coming from the Jet Propulsion Laboratory representing government. We have 1 coming from AMSAT that represents a nonprofit organization. And we have 2 coming from universities representing academia. And all 4 of these spacecraft are looking into various aspects of technology development, scientific research, and educational outreach. All 4 of these teams have worked extremely hard to get their hardware ready to go fly, and we're very, very proud of them. Not only did they have to build and test a spacecraft, they had to produce a lot of objective evidence to prove to us, to the NRO, and to United Launch Alliance and the Air Force that their hardware was safe to fly and would not harm the primary mission or hurt the public. And they've done an excellent job. And they're going to speak to you here at the next press conference about what it took to build their satellites and what these satellites are going to do. So I won't steal any of their thunder. In conclusion, I want to thank the NRO, in particular the Office of Space Launch, for their outstanding leadership in pulling this mission together. I should also recognize their integration contractor, SRI, who did a magnificent job. All these people, and ULA, all these people did a wonderful job of making a very hard task look easy. And because of their efforts, we're ready to go fly tomorrow. So with that, go L55, go Grace, go Ilana 12. Mike?
Thank you, Scott, and thank you, everybody. We're ready now to take questions, and we'll be taking questions from those on the phone and online. And as a reminder, if you're watching from afar, please make sure to send your questions on social media using the hashtag AskNASA. And for reporters on the telephone, don't forget to hit *1 to be placed into the queue for questions. And when you're called on, please state your name, your affiliation, and to whom you're addressing your question. We'll take one question, and then if time allows, we'll be happy to go back for follow-up questions. And also, because we have such a large panel, please be mindful that we have limited time, and we'd like to ask that you keep your questions focused on the panel's topic today, which is the use of CubeSats in space exploration. We will not be discussing any details about tomorrow's launch. So we'll begin with questions here with Kimberly Williams from Ames Research Center, NASA's Ames Research Center. She has been following incoming questions on the hashtag AskNASA. Kimberly?
Our first question for today would be directed to Scott. Students are watching this launch and the press briefing during their lunchtime. How can more of them get involved? And can this be related to humanities classes and not just STEM?
Okay, well, how you can get involved. Put together a proposal for building a spacecraft and submit it to NASA. We put out a call for CubeSat Launch Initiative projects every year. I think call 7 is underway right now. Propose a satellite that meets some NASA objectives in educational outreach, technology development, or science and exploration. Get it funded, and we'll provide the launch to you if you're selected. But that's not the only way to get involved. There's all sorts of things. You can look at our NASA website. We have a tremendous educational outreach organization that works with schools, both primary schools all the way up through colleges around the country, providing a variety of different ways that you can get involved. But building spacecraft are cool. You know, that's a neat thing to go do if you can pull it off. And I highly encourage you to do it. In fact, we have our first elementary school has built a CubeSat, and it's already been turned over and packaged for launch. It's going up in December on the Ilana 9 mission up to the space station to be deployed. So if an elementary school can do it, so can you. As far as humanities are concerned, well, that's tough because I'm an engineer. And but I think that for me, imagery from space has an artistic quality to it, and perhaps that's a way that you can express yourself by gathering images of this beautiful planet that we live on.
Okay. All right, Kimberly, do you have any other questions that you can pass on to us?
This would be directed to NASA. What does NASA expect to learn from technology demonstrations with small satellites?
So we learn a tremendous amount about developing technology and testing it on Earth, and including in simulated space environment. We put hardware on vibration tables to simulate the launch environment. We put them in vacuum chambers and cycle the hardware hot and cold. But it does not fully simulate the space environment and going into space. So the first thing is testing the technologies as they're intended to use in the system in low Earth orbit. That is critical to eventually being able to use technologies in exploration missions and science missions. And so on OCSD, we're trying to mature laser communications technology, and like Scott said, increase the ability to get larger amounts of data from low Earth orbit to the ground. But we're also advancing, like Andrew mentioned, propulsion technologies, attitude determination control system technologies, power system technologies. And our goal is to make these platforms more capable, along with the instrumentation that goes on them, to do real meaningful exploration and science missions.
Just a reminder for the reporters that are on the phone, we have a number of reporters on the phone, but nobody is into the question queue. So a reminder, if you have a question, don't forget you need to push *1 to get into the question queue. And also, again, for social media, it's #AskNASA. Kimberly?
And our last question at the moment is for Sherry. Why are laser communications so important in this mission?
This is development, and my colleague Dr. Rich Welly will discuss it a little bit more in the next panel, but this is a demonstration of how small we can make the optical lasers, and whether or not we can have sufficient pointing accuracy of the CubeSats so that we can actually fulfill the mission. So a lot of this is what we would call a technology demonstration, and we will fly this laser and learn how to make it better and have a better laser on the next one.
Okay, why don't we see if we have any questions in the room from anyone in the audience who would like to ask the panel. Do we have any questions? Just raise your hand. Okay.
If I could expand upon Sherry's answer
Yeah.
a second ago. I think one of the things that makes new space interesting is, given the very low cost of producing each iteration of small satellites, means that it's almost like software development, Scrum-based software development, where you can come up with the next iteration to build and launch for a couple $100,000. And that's exciting because to create where we are with 200 megabits per second and then get to 622 megabits per second within only a few months, that's a capability that could never be achieved when you're talking about much larger satellites that require years upon years of development efforts and billions of dollars. And so that's one of the benefits that we really appreciate about being investors in low Earth orbit is the speed to market with each new iteration.
Okay, thank you. We do have a caller on the phone bridge, Dan from Fox News. Dan, go ahead, please.
Hey guys, quick question regarding the CubeSats and the single-use nature of them, the ease of making them. I know that's one of the things that's emphasized, to school groups. I'm wondering, this technology evolves, how much more complicated and sophisticated do you expect that this technology will be able to get? Kind of using the analogy of our phones being able to do what a giant supercomputer used to do, 30, 40 years ago. Do we see CubeSats really taking over some of the uses of what, larger traditional satellites would do?
I might address that one. It's not that we see CubeSats or small spacecraft replacing larger satellites completely, but we think there are some unique applications for which small satellites might even be better than larger ones. If you want to do distributed measurements over a large area and collect that data, that's what we're demonstrating with the Edison mission. And the time frame that we talked about, the ability to fly a mission quickly, learn from it, and turn around and fly another one very quickly is something you don't get with large multi-billion-dollar projects that take 5 or 10 years or more to begin. So we see it driving innovation, and we see it providing very unique new capabilities that will supplement and complement what we do with larger satellites.
And if I could just augment that, aerospace has been looking at different constellations, and it may be possible with constellations of small sats to do different types of work, as well as doing a mixed constellation, using large satellites and small satellites to accomplish different tasks. You might imagine a small satellite being deployed from something larger and looking to see if there's an anomaly, if we could understand why, because it would have an upfront view of what's going on. So there are lots of different kinds of missions that CubeSats may be possible of doing, or swarms of small sats that large satellites just can't. Thank you.
I think the miniaturization of satellite componentry, the advances in digital signal processing, it's also a great story monetarily. What once took billions of dollars and years for us to build and launch a very sophisticated, exquisite asset up into GEO now can be done, maybe not the entire full package of capabilities, but for hundreds of thousands or small millions of dollars in months. And that's a very interesting proposition, particularly to the American taxpayer, who now can see many of those capabilities replicated with a much higher return on invested capital.
Before we go back to Kimberly for some questions online, we do have a question in the back of the room.
Hi, I'm Jerry Buxton with AMSAT, and regarding the access to space through the CSLI and the Alana program, we have our NROL 55 tomorrow, and Scott mentioned Alana 9 going to the ISS. What are the types of launches, opportunities, what's the scope of that NASA looks at in order to be able to provide these opportunities to the SmallSats?
I'll take that. Basically, we look for the right vehicle going to the right place at the right time at the right price. Not every CubeSat is, for time-wise, not every CubeSat's ready to go when the rocket's ready to go. And since we're flying along in the excess capacity of the rocket for the most part, we got to go when they go. So we have to align the CubeSat projects with the rocket that's going in that direction. Then we got to worry about where they're going, the place. Are they going to the right inclination for you to do your science? Or in some cases, for you to be able to talk to your satellite. A lot of the teams we work with have a single ground station. They're in a place on the planet, and not all orbits go over that ground station, and so they need us to be able to put them in the right place. So that flight may not be the right flight for them. Same thing with altitude. Not every altitude is good for every satellite. As you probably all know, we try to minimize the amount of time a spacecraft is in orbit after its lifetime is complete so that it doesn't become a piece of floating space junk. And so we have rules in place about how long they can stay in orbit, and we have to adhere to those, and those limit us to certain altitudes. And then there's price. We are servants of the taxpayers, and we are trying to find the best value for the buck to get as many satellites in space as cheaply as possible. And so we beg, borrow rides wherever we can get them, working with our other governmental partners, the Air Force, Space Test Program, the NRO. We also are starting to venture out into commercial operations and getting rides into space on commercial rockets, and also utilizing the commercial venue through the International Space Station to fly our satellites. And in the future, we hope to ultimately see very small dedicated launch vehicles that can be used for small satellites. Those are emerging, and I think are going to start to become more of an option for us in the future.
Thank you, Scott. Remember, for reporters online, it's *1 to get into the question queue, and for online, it's #AskNASA. And Kimberly, have you got some more questions for us?
Yes. This one is for Steve. Are there any joint ventures between ESA and NASA regarding small satellites?
Currently, we do not have any joint ventures between ESA and NASA on small satellites. But I think there's opportunity in the future to not only have international collaboration on small satellites, but also further international collaboration on developing technologies for human and robotic exploration of the solar system. I think I absolutely believe that in order to eventually get humans on the surface of Mars, it will absolutely need to be an international collaboration. The United States is not going to do it on its own. Just like the International Space Station was, an international collaboration that resulted in one of the greatest engineering achievements that mankind has ever accomplished. Not only from a technical and a cost standpoint should human exploration of the solar system be an international collaboration, but just for humanity, it ought to be international collaboration. And so we're going to continue to look for opportunities not only to collaborate with Europeans, ESA, and government individual country space agencies, but also more broadly internationally.
This question is for Andy. How is the CubeQuest Challenge different from the CubeSat initiative?
I think, they're talking about the CubeQuest Challenge is a prize competition that the Space Technology Mission Directorate is offering under the Centennial Challenges program, in which there's no funding for the development of a new capability. In this case, the capability of sending a CubeSat out into deep space and communicating back to Earth, and a second challenge of putting a CubeSat into orbit around the moon. But the for accomplishing that, they receive significant prize money to reward them for making that accomplishment. It's unlike the other things that NASA does, in which we normally fund the development of a project along with the research team that we're working with.
And one for NASA. Steve, has data rate testing for laser communications been tested, and what types of communication would benefit the most? Traffic, hydrology, etc.
Okay. So we've actually been developing laser communications technology for quite some time now. We did a very brief demonstration of laser communications from the moon directly back to Earth as part of a NASA mission. We are developing a couple of other technologies to allow very high bandwidth communications, 1 gigabit plus from geostationary orbit. That's the Laser Communications Relay Demonstration mission. And that could definitely revolutionize the commercial communications industry. There's a couple of things. A, laser comm is higher bandwidth. And then the second thing is we're going to a different part of the electromagnetic spectrum. The RF part of the spectrum is getting pretty crowded, and we keep chopping up that spectrum into smaller pieces that cram more satellites and more transponders in there. And so by going to a different part of the electromagnetic spectrum, light, we can open up a whole new bandwidth regime, sort of, to kind of sort of revolutionize commercial communications. And also we're developing deep space optical communications, which has challenges not only in laser transmitter power and receiver sensitivity, because you're definitely photon starved in deep space optical communications. You only have a few photons you're getting back to actually get the data back. But also, as was mentioned, pointing is a huge challenge for laser comm. And when you're talking about communications from the moon or Mars back to Earth, pointing and stability control is super critical. So we're hoping, as part of the next Discovery class mission out of the Science Mission Directorate, to demonstrate deep space optical communications on one of those missions, which will be really exciting and is going to be required both for, we mentioned how much data is lost in space for Earth orbiting spacecraft. Well, there's even more data lost in space from our Mars orbiting spacecraft. And I think it's going to take many months to get the data back from the Pluto mission. And so deep space optical communications offers, our ability to get a lot more data and a lot more science return for the deep space missions that we do.
Rich Welly, who is on our next panel, has a question.
Yes, good morning. I wanted to follow up on the earlier question about launch. As a CubeSat builder, we're always worried about access to space. And in the early days of the CubeSat world, it was the regular rides to space were not as available as they are now. And we understand that. We're along for the ride. We're there at the grace of the launch provider. But I think part of it is just getting the launch provider comfortable with the idea that CubeSats can fly and do no harm. And my question is addressed to Megan and Scott, who are dealing with the launch. Do you see the launch providers now as becoming fully comfortable with this, that rideshare will become very standardized as we go forward, that this issue has been resolved?
Well, I think right now, there's a lot of things that do concern the primary payload, so we are definitely in a do no harm state when it comes to CubeSats. And I think we'll continue to do that as we move forward with ride shares. Now, as ride shares become more predominant, I think we'll get into a pretty steady rhythm for what the requirements are for launching. And as the commercial dedicated launch segment opens up in the near term, I think we're going to see a little bit of a change in how we approach our launch to space. Would you say that's fair?
Yeah, to add on to that, we've been slowly improving the processes for evaluating the uniqueness of each spacecraft, and that is starting to allow, and the more experience that these providers get, the easier it is for us to get comfortable once they understand the data they're looking at. And so slowly we've been chipping away at allowing CubeSats to be more and more intriguing with some different capabilities. But it still, in the end, there's a risk calculus that has to be done where you decide whether it's worth taking the chance or not. So do I think we're going to see any RTGs on CubeSats anytime soon? Probably not. But are we going to be able to see things that maybe have propulsion systems that are a little more energetic? Absolutely. I think there's a variety of reasons why we all want to do that for end-of-life mission, end-of-mission purposes, and also for avoidance of conjunctions. But slowly we have to provide enough compelling evidence to show that this hardware doesn't represent an undue risk, and we'll get there.
Once again, if you're on the telephone, press *1 to get into the question queue, and if you're online, hashtag #AskNASA to get your question in. And Kimberly, do you have some more questions?
I have a question for Megan. When will the CubeSats be released? Will they be deployed all at once or separately? And how long will they remain operational?
So the process in which that you launch, standardly that the CubeSats are released after the primary payload, so again, not to interfere. They're usually staged from their deployment, so they have a deployment sequence, so they're not launched all at once in a large cloud. I'm sorry, what was the last part of that question?
You completed 2. Let's see, how long will they remain operational?
So CubeSat, their operational life varies depending upon the internal components, the size of the spacecraft, and what their mission is. So on average, we see CubeSats last anywhere from 1 to 2 years, just depending upon what their internal devices are.
My next question for Scott. What resources are available to help a new student team select and develop their very first CubeSat?
Okay. I would think in the academic community, talking to your colleagues from other schools. That's probably the first and foremost thing that I would recommend. There are a lot of academic institutions that have now gotten their feet wet and built their first spacecraft, and the CubeSat community, academic community especially, is still a very tight-knit community, and folks are more than willing to share their experiences. So that would be my first suggestion. The other one is reach out to industry. Industry, there are a wide variety of standard CubeSat parts that are now available that you can buy on the internet. We have actually, a new industry has been created with the SmallSat movement, and there are a variety of companies around the country, around the world that sell these parts, and they're willing to provide advice as well.
I'd like to add to that our program offers an opportunity for universities to propose projects to NASA. It's called SmallSat Technology Partnerships, and we're going to be doing this every year. University can propose a project that they want to do in relation to small spacecraft, including CubeSats. And in addition to the award we make to them, we provide up to one person of NASA labor to work with them so that they can collaborate with NASA, and NASA gets the benefit of the fresh ideas coming from the universities as well.
My last question is general, so I guess NASA or NRO or any of you guys could answer this. How long would it take a spacecraft this size to go to the moon?
That's a good question.
I'll start.
Yeah.
It depends on how hard you push it.
Yeah.
How much energy is put into that CubeSat. So yeah, I can't really answer that question without knowing how it's getting there. Different rockets have different capabilities, and so depending upon how hard they push it, and how much velocity they give to it, and how much it provides itself. Does it have its own onboard propulsion system? Can it propel itself? And how robust is that capability? So it depends.
Just to add a little to that, because we've looked at really doing it 2 different ways. One is, as Scott was saying, it can ride along on something already on its way to the moon, which makes it a lot easier for such a small spacecraft then to get there. We've also looked, at least in a preliminary way, at what it would take to have a very small spacecraft with its own propulsion system orbiting out away from the Earth, out toward the moon. In that kind of case, it might take maybe a year, 2 years, or even longer. But there are cases where that might be a very interesting type of mission that could be done with an electric propulsion system, a very low-cost way of getting a small payload to the moon. So we're looking at some more novel concepts like that as well.
Okay, that's all the time we have for today, and I would like to thank our panel and everyone who joined us today. Our next briefing will discuss the 5 NASA CubeSat missions launching tomorrow. The United Launch Alliance Atlas V rocket is set to launch at 5:49 a.m. Pacific time from Vandenburg Air Force Base, and our coverage on NASA television will begin at 5:19 a.m. Pacific, 8:19 a.m. Eastern time. This press conference will be available in about an hour from now and for the next 30 days for replay by calling 866-475-8046. And you can find out more about NASA's various CubeSat programs and missions by going to www.nasa.gov/CubeSats. Thank you.